Hi, my name's Mark Briscoe and I'm a product marketing manager with Tektronix. In this demonstration, I'm going to show how the 6 Series MSO can be used to troubleshoot a typical embedded system that might include a microcontroller, digital to analog converter, and a serial bus. For this demonstration, I'm using the MDO demo board, which contains a microcontroller that programs a digital to analog converter via a 3-wire SPI or serial peripheral interface bus. I have a TPP1000 analog probe connected to channel 1 and connected to the D to A converter output, which in this case is going to be a sine wave. And then I have a TLP058 8-channel digital probe connected to the 8-bit digital to analog converter input. And I have a second TLP058 probe connected to the 3-wire SPI interface. Now to take advantage, I'm going to take advantage of something that all 6 Series MSOs come with, and that is a set of demo session files. Now these files are designed to enable you to demonstrate most of the functionality of the instrument when you may not have live signals available. So I'm going to go ahead and do that by loading up one by going to the Utility Demo menu, and I'm going to select Digital Channels, Recall Demo Session. And what you'll see is that the actual setup of the oscilloscope will be done, and there'll actually be real data that was acquired when the session file was saved. Now this data gets put back into the acquisition data. That's why you see the output of that D to A converter showing up on channel 1 rather than a reference file. Now in this particular input, you can see in the upper section of the overview the actual sine wave there. We're zoomed in on a very narrow portion of this, so the sine wave actually looks like kind of a standard single value voltage output here. But we also have the 8-bit parallel bus input to the D to A converter, the 3-wire SPI bus waveforms here, as well as the parallel bus down here, which is reading out the decode of the parallel values in hex, and then the 3-wire SPI decode showing also the hex values of that. Now I can hit the run stop button and actually start acquiring active live signals from the demo board, and you can see the waveforms updating here on screen. I'm going to go ahead and hit single sequence just to acquire a single data set so we can talk a little bit more. The power of the 6 Series here is allowing you to trace through the system what's happening. And if we start over here on the bottom with the serial bus interface, you can see a 6-0 hex. Now that 6-0 hex gets sent to the digital to analog converter. We see it show up on the input to that converter here just a little bit further out in time as a 6-0H. And then the next value gets programmed in at 5-4H, and it shows up on the value at the output or the input of the D to A converter. The net result then, of course, is that those values get translated into the digital to analog converter's output, which is an analog trace, in this case a voltage value. And when this is done over and over and over again, we output a sine wave. With flex channels, the 6 Series MSO can easily capture many analog and digital channels. Multiple parallel and serial buses can be used to view signal interactions throughout complex mixed signal designs.